Hi, my name is Damiano Marsili from Caltech, and I'm going to be presenting our paper, Same or Not, Enhanced Visual Perception and Vision Language Models that was recently accepted to CVPR 2026 as a highlight, with all the authors shown on screen. I'm going to start by showing these two pictures and asking a very simple question. These are two pictures of vacuum cleaners, and I'm going to ask, are they the same instance? Are these the exact same object? Now, hopefully it takes us less than half a second to realize that the dustbin geometries are different, the color themes are different, the handles are a little bit different, and so clearly these are not the same object. But it turns out if you take this question and you ask it to some open source VLMs, you'll unfortunately get an answer of yes. They will focus on a lot of generic features like very broad descriptions of the color, very broad geometric descriptions of the shape, and it'll turn out that this model will say yes. And just to spoil the surprise a little bit, it turns out we can do something about that, which I will discuss in the rest of this presentation. Okay, so we first start with trying to understand why these models still struggle on this task, right? These are models that have made phenomenal progress in recent years, and yet this seemingly trivial and easy task is still quite elusive. And so we hypothesize that one of the reasons for this is that there's just not a lot of large-scale training data sets for fine-grained understanding. So what I'm showing on screen is the data mix used to train a recent VLM, an open source VLM called Perception LM out of Mehta. And you'll see that there's a ton of different data sets spanning millions of queries. And of all of these data sets, only two, Birds to Words and Spot the Diff, actually focus on fine-grained image understanding. And each of these, you'll notice, have less than 20,000 samples. So really a drop in the bucket of all of training samples that these models see actually focuses on fine-grained visual understanding. And so it's obvious that if we want to make progress on this task and we want open source models to improve at it, we need more large-scale training data sets that emphasize fine-grained image understanding in VLMs. And so in this work, we propose the Twin dataset. This is a dataset that we built, which features 561,000 VQA queries. Now in Twin, VQA queries are of the form that I showed in the first slide. We have a pair of images, which in the positive pairs case show the same object, in the negative pairs case show similar but distinct objects, and VLMs are asked simply, do they show the same object, with some minor explanation of what it means for an object to be the same instance. We source all of our pairs, all of our instances from Amazon reviews, and we focus on household objects, and we compose this data set with 561,000 pairs of 1,836 instances that span 36 different household object categories, and the distribution is shown on the right. Now, on top of there not being large-scale training data sets, there's actually quite a big gap in the benchmark space for testing fine-grained VQA. And so in this work, we also build what we're calling the FGVQA, fine-grained VQA benchmark suite, which features fine-grained VQA tasks spanning a bunch of different domains, 6 domains to be precise. So Twin eval is the eval set of our twin data set. So these are pairs of household objects. Inquire are animals from iNaturalist, animals and plants from iNaturalist. Landmarks are images of landmarks. Cub is a bird data set. Ilias is also a retail and home object data set. And Met is an artwork and landmark data set. And we construct this benchmark with 2 query types. So the first is pairwise, which is shown in the top row, which is very similar to the setting I described in the previous slide. Shown 2 images, do they depict the same blank, where blank is either object or landmark or bird or whatever. And then we also have a multiple choice variant, which is the one shown in the bottom row, whereby each query is shown a reference image and then a bunch of other test images, and a VLM has to determine which of the test images include the sample instance shown in the reference image. And so each constituent benchmark has queries of both type. We're just showing them separately on this slide for conciseness. Okay, and so it turns out we can take this very large twin data set and we can do some very simple post-training with the twin data set. So we can take a VLM and we can do some very simple post-training with GRPO, where the only thing we're doing is asking the query, are they the same object, and then using a very simple answer reward. And we made the training super simple on purpose to show that the data itself can actually get you a very, very far without needing any sophisticated post-training algorithm. And it turns out If you take the models, you train them on this twin data set, they actually improve at fine-grained understanding quite significantly. And importantly, the thing I want to point out is that the improvements are not just limited to in-domain examples. So in those, this would be the twin eval and alias, the one at the top and top right. Those are our in-domain distribution data sets, and those do see a big jump. But actually, we also see a big improvement to fine-grained understanding for out-of-domain data sets like Cub, Inquire, Landmarks, and Met. And what we see is our model does actually learn to pay attention to very fine-grained cues in the image by training on those household objects. And here I'm showing results for Quen 2.5 VL. We have results for Intern 3.5 VL in the paper as well. And just very quickly, I want to show a qualitative example that we can actually look, and there's of course many more in the paper, you can actually look at the reasoning traces and see the model improve at detecting fine-grained differences. In this case, the post-trained model is able to detect the difference in color between the hands and the dial in the second clock, as opposed to the first one, and the pre-trained model that says they are the exact same color. So that's all for me. Thank you so much for watching. Here I've included some links to our project page, paper, dataset, benchmark models. Everything is open source. Please feel free to check it out. Thank you.